So again, the projects I handed back your engineering notebooks. Right, so I kept saying there are two things you're submitting. Some stuff you do in the engineering notebook, and you give those to me. Right, that's why I had you turn them in, went through them and graded them. Basically, if you had, say, 3 sketches, I gave you points. Right, the deliverables was the things that you needed to do for this class, or this project, excuse me. So what I did was I went through the engineering notebook and I looked at, hey, do you have A, B, C, D, E, whatever? If you didn't, I didn't give you points, right? If you didn't have 3 sketches, I can't give you any points. The engineering notebook should have had 3 sketches, like 3 ideas that you just jotted down. Like we're going to maybe do a cylinder, maybe do a triangle one, and then a normal rectangle one. Just give me 3 sketches. That was all you need to do. 3 ideas. The decision matrix you needed to have in there. That was one of the deliverables. Right? My PLTW had a link that told you what a decision matrix was. So I just needed you to make yours for your 3 designs, pick categories that you thought were important, rank them, and whoever gets the biggest score, that's the design you chose. I just needed to see a decision matrix to show that you went through that process of how do I know which design is the best. The other thing, the material volume. A lot of you guys didn't include that. I was kind of surprised by how few people asked me about that, right? Because you might be like, what the heck is that? Well, it was literally just highlighting your part in Onshape and clicking a button in the bottom right. It told you the volume of the object. I just needed that documented, right? One of the criteria was you can't have, I think I said 23,000 cubic millimeters. It was basically the amount of material you use for your part. You needed to be under that threshold. So you just needed to document like, hey, here was the volume of our part. You just needed to record it. A lot of you guys didn't take the time to make that step happen. And then the other thing in the engineering notebook was a proof of concept statement. Again, on Classroom, I think specifically the design brief. When the list of the deliverables, that statement I put in parentheses step 11. A lot of you would ask me, like, wait, Mr. H, what is this? And I showed you the design brief says, hey, that's step 11. It was just like 3 questions from my PLTW. Answering those 3 questions gives you your proof of concept statement. You don't have to come up with it on your own. You just respond to those 3 specific questions to make that statement. Again, I just needed that documented, either in the notebook or the design brief. It should have been in the notebook. I don't think anybody put it in the design brief, but I looked for it, and if it wasn't there, I can't give you points for something that's not there. The second submission that you did is in Classroom. I needed to see the design brief. You guys did it together as a group, right? Virtual students, if you work independently, you made your own, but you needed to submit a design brief. A lot of you guys, some of you guys, one person would submit the design brief and one person wouldn't. Well, I can't really give you points if you didn't submit it, right? I know you did it together, so it should just make a copy and attach it. And I had mentioned on the Classroom submission, I need each of you to submit your group's design brief, your dimension multi-view drawing, and your partners, right? That was just so I didn't have to go back and forth. I don't think I took off if you didn't submit your partner's multi-view like I had asked you to. But the big thing was your own multi-view drawing, right? You need to make a part, dimension it, and give me a PDF multi-view and submit that. Make sure your name's on that document. That was the biggest part. That was, I think, 20 points by itself. Everything else that I listed was just 10 points apiece, right? The deliverables list, everything on there was 10 points. The 3D model and the dimension multi-view, I merged into one 20-point assignment, which was basically if you made a PDF multi-view, you had to have made the part, so I gave you those 10 points as well. So again, the scores were not what I thought they would be. I was a little surprised by the outcome, given that, again, you guys had a week. I gave you like 3 full class periods to do it. I was here the whole time just waiting for questions to try and help you guys figure this out. So I was kind of bummed that you guys didn't do as well as I thought. given the time you had, resources. But regardless, I put the grades in Power School, right? And in the comments, I put, what you missed and what points you got taken off, so like, oh crap, I missed 30 points because I didn't have the sketches or the decision matrix or the material volume. So it's in there. Now the thing is, grading quarter, again, is coming up this Wednesday. 2:30 p.m., end of the school day on Wednesday, grades are done, right? So you guys still can get some late work, right? If you missed like all of your engineering notebook, like just get it done, turn it into me, and I can give you half the credit. It's a lot better for especially a project, but that has to happen by Wednesday. So if you want to get some points back on this assignment, right, or you forgot to attach your design brief, resubmit it. I'll get a notification that you're submitting it late, and I'll go in, grade it. I'll update your grade, but it has to happen by 2:30 on Wednesday. After that, I can't do anything for you. The grades are going to be set at what they are. Same thing for missing assignments. If you still have missing assignments, get them done. Like ASAP. In the words of Michael Scott, ASAP as possible. Seriously, please get them done.
I'm working on it.
I appreciate that. Again, I do not want to give you bad grades, but the problem is I'm not giving you the grade. Like, you guys are responsible for your grade. If you do the work, you get a certain grade. If you don't do any work, you get that grade, right? I am not out to get you guys. I am not being unfair at all. I'm not giving you a bad grade. You get what you get. I just need you to do your half and get me your work, get it turned in, do it ASAP. All right? Are there any questions at all about the project or grades or how I graded it? Anything that I can clarify? Anything at all? Okay. What I have today, it should be a light day, partially because on Friday I had engineering students and they had homecoming, and one, they were rowdy, as you can imagine, and two, I understood it was Friday homecoming, so I did not plan. I basically planned half of the day. So we're going to do that as well. It'll be a light day. I'll try to get through this, and then any free time we have, I want you to get work done, right? But also, if you want to make the choice that I don't want to do my work, I just want to hang out, that's fine. Just know that we'll have some spare time to hang out before I get through this. Drew?
The stuff that we do today and Wednesday, will that be put into the grading period?
Today there's no grade being added. Wednesday I also won't. I don't think we'll have anything graded either. So no, there won't be. Like this project is the last thing that I'll put in the grade book. Yeah, good question. Today we're not turning anything in. Wednesday also, I think it'll be in class. All right. Okay, so let me get this queued up. Where am I at? Okay, so, oh yeah, I did it. Also, I didn't even notice this, but teachers, we didn't win the relay, right?
No.
No.
You were fast though. Like you ran down there and we're like, dang, he's zooming.
Thank you. I was hauling because one, I didn't know it was like a track relay. I thought it was like an egg and spoon, like a fun game relay. So I was like, oh crap, I haven't run in years. And so then when we got up there, they were saying, oh, we need 8 people. And I was like, we got a team of 4 teachers. How are we going to run a relay with this? So they were scrambling to get people. And so, like, I did my first leg, right? Like, I went all out. I was heaving. And I was sitting down there. And the last person was coming on the relay. And I was like, why is he coming back? And I looked, and there was only 3 teachers. We started the relay with 7 people, not 8. So that's why I had to run a second time, is because I was like, well, crap. Nobody else is going to do it. So I was already gassed. Like halfway down my second run, I was like, I was out of it. I was like morphing into a jog, but I gave my best effort. I was actually a little winded.
Yeah.
Like I wasn't feeling so hot after that. But I appreciate it. At least you saw that I gave my effort, right? I did try.
Talk about being fast. Josh O'Connell passed him.
Yeah. But anyway, that was pretty fun. Also, they didn't do the tug of war against teachers.
He did it?
Did anybody notice that?
No.
Right? I didn't miss it, did I? They didn't do a student-teacher tug of war, correct?
Mm-hmm.
Okay, because I was supposed to be in that, and then everything was done, and I was like, hold up, did I miss my event? But anyway, they must not have done it. Okay.
Run a complaint.
Complain. Okay, you guys. Is this? Nope, it's not up. But yes, thank you. I at least tried for the first leg of my relay. It's more workout that I've done in the past month. So you guys, one, I need you guys to get your phones away, right? Shouldn't have them out. I don't want to see them. Today, what we're doing, we're starting Unit 2 officially. So the first unit was, I don't even know what they called it, honestly. Yes, thank you. Design and problem solving was the first unit, right? This class is split into 4 main units. So we've got through the first one about, engineering design and just basic problem solving, right? Now, Unit 2 is technically called assembly design. So now the real shift that we're going towards is, okay, we've learned how kind of engineers have started to think. We've learned how to use the 3D modeling software, right? An engineer's primary tool for designing things. And we've figured out how to design stuff, right? We know how to use the software. We have done a project where I've given you a problem statement and you've actually given me a design of a product and made that design, right? Now what we're doing is we're going to say, okay, take it a step further. Instead of making singular parts, we're going to start making multiple parts and assemble them together, right? We're going to make, I guess you could call them machines in a very, very vague sense. Like you have multiple parts that interact and work together, right? So if we redid this project after learning things about assembly design, you guys could do as many parts as you wanted. So you'd make the bottom case with the hinge. You'd make another part, like the rod that acts as the hinge itself, and you assemble that into your bottom part. You could make the lid as well, assemble that all together. You could make like a lock pin. Some of you guys were going to do like a sliding lock pin. That would be another part, and you assemble them all in the same 3D space. And you can show like they fit together in this certain way so that the motion only, hinges because I assembled them in a certain way. That's the goal, is to start putting multiple pieces to make an assembly, to make animations on how it works, things like that. So to start with, however, 211 is where we're at to begin with. This activity topic is about tolerances. Does anybody have an idea of what a tolerance is for an engineer? Adrian? Yes. Good. Malachi, what were you going to say?
I was going to say how much
What's that? That's okay. That's all right. Yeah, Adrian had a good summary of it. It's how far away from the actual measurement something can be. Your tolerance is, I want this part to be 1 inch plus or minus 1/4 inch. The tolerance is this window, this room for error that you have when you actually make the part that you're designing. So I want to walk through these together. I'm going to basically go through this activity instead of having you guys do it. We're going to work through it together. The first thing you'll notice is there's a resource link with that lays out the different types of tolerances that engineers use, right? Maybe see better. Tolerances change depending on your application. If tolerance is the room for error of your part, which of these items, if you're going to design these items, which one would have smaller tolerances? Less room for error?
The building blocks.
No, I wouldn't think so. Engine parts.
No, it would be I thought you meant like.
Yeah, I think you were thinking about it backwards.
Would result in less consequences.
Gotcha. Yes. No. The smaller tolerances, aka smaller room for error, would be an engine part. As an engineer, I need these parts to be precise, right? The piston inside that engine, it has to be close to the design size. If it's too far off, it either won't fit or it won't work. Okay. If these parts don't work, the product doesn't work. Or if these parts fail, people potentially die.
Yeah,
right?
That's what I was saying.
There's a lot more at stake here. If I build toy building blocks for kids and they're off by 1/4 inch, I don't think that's a big deal, right? 3-year-olds don't need their building blocks to have a high level of tolerance, right? So why would I make building blocks to the 1,000th of an inch? Because that's very expensive and hard to do. Well, I'm going to make them to the 1/4 inch, right? If it's close enough, I'm good to go. So my tolerance is here. I have a lot more tolerance, more room for error than I do here. You as an engineer, when you design things, you decide the level of tolerance that you want. You want you do not want a lot of room for error, right? Wouldn't you want your part to be exactly what you design it to be? We all would. But we can't do that. You can't have a hole be precisely 1/2 inch. You have to give the machinist, the production line, room for error. Now, the room for error you give them, you need to make as small as possible so that it still works. But the more room for error you can give, the easier it is on the production line, and the less parts you have to throw away. If you measure a part and it's not in your specs, you got to throw it out. Right? So the application for tolerances is a big deal. There's 3 main types of tolerances that engineers use. The first type is called a unilateral tolerance. Well, unilateral, if you think about that word, should make sense. The prefix uni is 1, right? Unicycle. Universe, right? 1 verse. I don't know the Latin for verse, right? Lateral is like side to side or direction. This is saying 1 direction. Now, if you look over here, this is how we write them. Is that visible? There's a tolerance, right? The dimension is right here. The diameter of this hole is 0.5 plus 0.004 minus 0.000. Do you see how anything less than 1/2 inch is unacceptable? They gave no tolerance in the negative direction, right? A hole that's 0.499999 inches is not acceptable. Now, I could have my hole be 0.501, because I'm giving you some tolerance on the positive side. The tolerance, the room for error, is only in one direction. That's a unilateral tolerance. That should make sense, right?
Yeah.
I only give you room for error in one direction. The second type, lo and behold, is a bilateral tolerance. I give you tolerance, room for error, in two different directions. Here's what I want my part to be. You can go a little bit above or a little bit below. My part, the whole depth, needs to be 0.25 plus or minus 0.003. This hole could be 0.253. It could also be 0.247. As long as it's within that window, I'm good. Notice the tolerance, the room for error, goes both directions. This is what I want. If I lived in a perfect world, this is what it would be. But I know we don't. So I say you can go above or below. Bilateral tolerance means the tolerance is in two directions. The final type that tolerances can be written as is a limit dimension. Right? Well, I guess you guys... Sorry about that. Again, unilateral tolerance for that first one. I only give room for error in one direction. Bilateral, I give it in both. Plus or minus. You have room for error in either direction. The limit is something where you list the limits, right? A limit dimension means I don't really tell you what it should be, right? I'm not telling you it has to be half an inch. I'm just telling you as long as it's between here and here, I'm happy. That's what a limit dimension is. Here's my upper limit, here's my lower limit. As long as you're within there, I'm good. That's a third type of tolerance. Another important thing that I want to point out, when I say the tolerance, what I'm saying is the room for error, the margin for error. If you have a dimension with a bilateral tolerance, meaning above and below, the total tolerance is how much error you can have. You basically add up 0.05 here, 0.05 here. My total tolerance is 0.1. You basically take the upper limit minus the lower limit. So what I want to do is work through these together. Let me try to make this a little bigger. You guys see that? So what we have is a part drawing, and we're given certain dimensions with tolerances. We have to identify what type they are. So if you look at dimension A, there's 4 holes at 0.138 plus or minus 0.001. What type of tolerance did they list in letter A?
Bilateral.
Anybody else? Can I have you guys put your math books away for a second? I need you guys to be with me here. Adrian? Yes. Good try. They were saying bilateral because you're seeing a plus and minus. I'm giving you room for error above or below my specified dimension. Now, what's the total tolerance that you're allowed on this part?
0.002.
Yes, 0.002. The total tolerance means the total room for error. Well, I could go 0.001 above or 0.001 below. Well, if I add both of those up, my total room for error is 0.002. Good. B, 0.25 inch diameter hole, plus or minus 0.001. What type of tolerance? Bilateral. Same thing. I give you two directions to make an error, basically. What's the total tolerance? What? Correct. 0.002. If I give you error in two directions, I need to add up both of those to say, hey, you have a total room for error of 0.002. How about C down here? What type of dimension, or excuse me, tolerance is listed here? There's three types: unilateral tolerance, bilateral, or limit dimension. Yeah, heard a couple of you guys. Limit, right? Correct. That's exactly right. They tell you the limits. Here's my upper limit. Here's my lower limit. Anything in there, I don't care. This literally tells you the limit. Now, what is the total tolerance of that dimension?
0.01.
Correct. 0.01. Anytime you want to take the upper limit minus the lower limit, well, it's already given. The range between the upper and lower limit is 0.01. So that is your total tolerance. Alright. D, down here. What type? Bilateral, plus or minus. You can have error above or below my dimension. Total tolerance? 0.004, good. Right, my total range is I can go 0.02 above, 0.02 below. E, what type of dimension? Unilateral. They list a plus and minus, but they give you plus 0. Well, your tolerance of 0 means there is no tolerance. I cannot go bigger than 2.225. Or 2.25, excuse me. I could be a little less than that, and my tolerance is 0.01. What's the total tolerance of that dimension? 0.01. Right, my upper and lower limit, where I add the two tolerances, well, 0 plus 0.01 is 0.01. Now, some of you guys might be wondering, why do you take the time to write out plus 0 tolerance? Why would someone bother to write that? Why would they just not include a tolerance on the positive side if they want it to be exactly that? Anybody have any ideas of why you would take the time to write that?
Like if it's like a blueprint or something?
Yeah,
Like
this basically
layout,
is.
like a layout of what you're making. You don't want to forget what it is, or forget like what it's made.
Yeah, that's good. Any other thoughts? Probably, do you have one or no?
It would be so that people wouldn't think I could go over this.
Yeah,
Just to remind them that you can't go any higher.
that's a great thought. Both of you guys are right. This is the goal is someone would make this, or you would propose this to like your boss. Like, here's my design, here's what I'm going to do. Well, the key is someone's going to make this. They're literally going to take this drawing and be like, how do I make this part? Well, they're going to make it by looking at all your dimensions. Tyler's right. If I don't specify there's no tolerance on the upper side of this dimension, the machinist would be like, well, they didn't tell me I couldn't go over, so maybe if this is 2.3, I'm fine. You bother to put this in to say, like, this cannot go larger than this dimension. It's to make sure that your design is made the way you want. If you didn't list any tolerances, you're technically telling the machinist, hey, do whatever you want. Like, try to get it 2.25, but if it's 1.5, well, good enough. So you would bother to take this time. This might seem redundant, but it's so that you're clear of what you're expecting, right? What's an example of when you would list a tolerance like this? you would not allow a part to be any bigger. Think of something?
Let's say you're trying to fit something in an enclosed space and it has to be a certain size. It can't be any bigger or else it won't fit.
Yes, that's a great point.
The
Drew?
protective case.
Yeah. What specifically?
It had to be a certain size or the headphones wouldn't fit in.
Right. Yeah. Another one, like, if you were talking being really precise, if you made your hinge and you have a pin that needs to go in the hinge so that it actually works, this is where you would place an upper limit on, like, the pin diameter. If your hole is 1/2 inch, well, you'd want to give no tolerance on the pin on the upper side. You can let them make the pin smaller because it'll still fit. But if you would give them room for error on the upper side, it might be 0.55 inches. Well, would a 0.55 inch pin fit in a 0.5 inch hole? No. It completely fails. So, Kyle, that's a great example. This is times when you would need to go out of your way to specify certain dimensions. Really quickly, looking at another part, what's F? What type of dimension or tolerance? Unilateral. You only give room for error in one direction. Unilateral. Total tolerance? 0.02. The total room for error is only one direction, so that's it. G, what type of tolerance? Limit. Yeah, it's a limit because it tells you the numbers. It doesn't tell you this dimension plus or minus. It just says, hey, as long as it's less than this or greater than this, I'm good. It tells you the limits for that dimension. Total tolerance for that part, or that feature.
Is 0.
What?
Is 0, right?
No.
0.03.
Total tolerance. What's your total room for error? Upper limit minus lower limit. 0.03. I have 0.03 inches of error that I can go within. That's my tolerance window. And then H. This is a plus minus in case you can't see.
I thought that was like a...
It's as clear as I can make it. But this is bilateral. I give you room for error in two directions. Total tolerance? 0.04. Good. Right? This is just to make sure that you can identify the types of tolerances, because eventually you're going to have to use them. You're going to have to say, I need to tolerance my part. What kind of tolerance do I want and why? Sometimes you might think it can't be larger than this, so I'm going to use a unilateral. If I'm going to say I don't really care either way, I'm going to give bilateral. Sometimes you might choose to list it as a limit, right? So now what I want you guys to do, again, I'm modifying a lot of this stuff. What I'm going to have you do, they're over here. So I have 2 blocks that I made. Alright, so if you see these, I got block A has 3 different sized holes. They're very similar, but they're different holes. Block B is the same thing, 3 different sized holes. What I need you guys to do, I'm going to have you guys try and work like group 1, group 2, group 3, group 4, group 5, and then you guys can join whatever. Luke, you with us? So in your 5 groups, I'm going to give you this. You guys can take turns, or one of you can measure them all. I'm going to give you dial calipers, and I want you to take block A and measure the diameter of hole 1 as accurately as you can. Right? So use the top part of the dial caliper, those prongs that move outward, until they're kind of snug in the hole, and then take a reading. And then what I want you to do is, if you get on Classroom, you could have one person in your group do this. They can be the recorder or whatever. You're going to hop on Classroom and open this shared Google Sheet. Right? Group 1, 2, 3, 4, 5. And you guys can join whoever doesn't. You can turn around and work with group 5. Put in your data for block A or B. Say, hey, block A, hole number 1 is 0.183 inches. I want you to record your group's measurement. Measure 1, 2, 3, and then give this block to another group. Eventually, you'll get a chance to get block B. Do the same thing. Group 1 would record their hole measurements for block B. Then what we're going to do is we're going to do a little bit of data analysis, and I'm going to talk about, again, the tolerance of these parts. So I'll give you guys block A and a dial caliper. You guys, I'll give block B. So again, try to take your measurements fairly quickly so that you can pass that block on to another group. And then, again, be careful with the dial calipers, right? Please be respectful of that instrument. It's sensitive. Move it slowly. Don't jerk on it. Move it slowly. Be gentle with it. They're very finicky, right? They're very precise. So you got to be careful with them. And they're also very expensive. Don't break them. So that's what you guys are working on. What's that? No. Well, I guess it's just you two. I went like 1, 2, 3, 4, 5. So,
All right.
you know how to read it?
Oh, yeah.
Oh, material volume. Okay.
2.7.
Our thing, like, 'cause I was looking at it,
Halfway through the
because I
Was that whole one?
whatever.
Yeah. Alright. 0.296. Wait. Am I just retarded? Change those to ones instead of twos. These numbers are. I'm just retarded.
So one, this shouldn't have happened. I don't know why. The only thing I can think is if you made a drawing or you switched the workspace unit, it'll keep it.
Yeah, I understand that. But it's when we have used it.
Yeah, just three.
Well, this I can give. And I can give you. Yeah, I can give those points back. Thank you. Is that you in? Did I fix yours? You would email me. Yes. Once you have the 3 measurements of your block, give that to another group right away so that they can go in and get their measurements, right? As soon as you get your block's measurements, give it to somebody else so they can get theirs. We need to fill that sheet out. And when we can, then we can move on. Let me do that before. What?
There's a dog falling.
Alright, I gotta focus on this, Hunter. Oh, that's... Years. Again, work on getting these dimensions in so that we can move forward. Oh, so it's 0.2, right? You can see the full start beginning of 2. So 0.2, and then you add these 2 digits to the end. So that's, what, 29?
Yeah.
So it'd be 0.229. Does that make sense?
What group are we?
I had you guys at 3. Yeah. Yep. Does that make sense?
We're blocking it. This is blocking it.
Yeah. Yep. Make sure you put it in the right block and get hole 1, 2, 3 for that block. And as soon as you're done, make sure to pass that block to another group so that we can get this table filled in. Okay?
What group is me and Luke in again?
You can join whoever's, right? I mean, you can technically join like Brody's group as long as they do it. It's not. It was just we need 5 different readings. So you guys can like help if you want. Otherwise, if they've got it, then you're good. Again, virtual students, you'll be able to have access to the same spreadsheet. So you can open it up with us and look at our numbers, right? We're just taking that block and measuring it all. And we're going to look at kind of important features about our data, our results from these measurements. Oh, yeah. We're getting there. Ready?
Someone wrote in block A.
Oh, who wrote block A group 5 spot? I guess it doesn't matter. Just fill in an open spot.
Someone's now doing group 5 block B.
Oh, we're group 4, aren't we?
Yeah, just stay 5, leave your numbers, you guys do it in group 4. Yeah, it's not a big deal, it was just somebody.
I forgot which group we were.
You're okay. Yeah, you guys be group 4. Yep. Okay. Yes, you can. A what? Yeah. Yep. Yeah. Yeah, basically. If you read, there's a link in the project My PLTW that tells you like, hey, this is how we do decision matrix. You basically, on 1, 2, 3, you have a bunch of categories like strength, durability, simplicity, and you literally will rank them. You pick your rank, right? But you need to tell me like 1 bad, 5 good. 1 horrible, 10 great. And then you rank them. Whoever gets the highest score, like if design 3 has 30 points out of 50, whatever, that's the best design. Now, if you're doing it after the fact, you need to make sure whatever design you pick ends up winning. Yes. So it's definitely not how it's supposed to be, but you're exactly right. You list your designs, give criteria, rank each of them according to those criteria, and whoever wins, that's the best design, then you would make it. Yep. Again, if you guys have adjustments or resubmit things for your assignment, I think just so that I don't lose my mind trying to keep track of everything, like if you're adding some stuff to your engineering notebook, take a picture and email me. That way I have a record and I can just go in my emails like oh, Jesse's adding some stuff to his engineering notebook. I'll check it and update your grade. All right. If it's something on the classroom, right? If you didn't attach your design brief, or you forgot your dimension multiview, like resubmit that in classroom, right? Attach what you're missing, resubmit it, and then I will see that in classroom. Actually, I take that back. If you guys are gonna resubmit something, anything for the project, do it through classroom. So even you guys in person, if you're resubmitting stuff on your engineering notebook, just take a picture and add it to classroom, resubmit it. That way I can update your classroom grade and your PowerSchool grade all in one. Because when you submit something late, I get notified, so that way I don't forget.
I need an extra comment.
On what?
On classroom, I need an extra comment.
Okay, yeah, if you comment something, I'll see it. Was it like a reminder to me of something?
No,
Brody.
I got my material.
Brody.
Okay,
That's up.
okay,
I put another comment on mine too.
okay.
Some stuff.
Oh, you're telling me you commented your material volume?
Yeah.
Okay, I understand. That'll work. I'll get that notification and I can update that. All right, are we close to filling this in, you guys?
Yeah, I just had to get the block.
Okay. Again, the goal of this is, say like we've got this part that was made, we're going to check the tolerance of this part, right? These holes. Jesse, I need you to put that away. Okay. All done? Block B, is that done? Some of you guys are missing hole 3. Did some of you guys not do hole 3 on block B? I see some missing spots. Alright, I guess we're just not going to do those. We're done with block A? Alright, did everybody get the holes measured? I see groups 2 and 3 forgot to do a hole. Hole 1, 2, and 3. I see hole 3 isn't. Right? Yeah. Oh yeah, there it's filled in. Okay, that's not ideal, but we can work with that. So what I'm going to do is I recorded, so I made these, right? They're pretty crappy. The drill bit is not good. It blew out the backside.
Is that a Jenga block?
No, well, not quite. There's like a construction building block set, and I pulled 2 of the same one. So what I did is hole A, or block A, in the middle, what did I do? I did a 3/16 inch hole. On the left side, I went down a drill bit to 11/16. On the right side, so hole 3, I went up to 13/64. So the design specification should be my drill bit size. If I use a 3/16 drill bit, my hole should measure 3/16 of an inch. Well, what we did is we measured it. I designed a part, picked the drill bit that I wanted, and I actually did it. We're going to see how the manufactured part compares to my design, what it should be. So what I'm going to do is I'm going to enter oops. Okay, so you see this? Oh, you cannot. Lo and behold. Alright, so you guys can see over here, if we look at block A, I had 3 different holes, and I listed the specified diameter. This is what it should have been. I, as the engineer, said, hey, this hole should be 3/16 of an inch. Now, perfect world doesn't exist, so it's not actually... How is this offset? Group 2, why do you have 2 inches for the whole diameter? 0.2? Can someone change that? Trey?
Why is the specified diameter so high on hole 1?
Is the formula wrong? Oh, did I record this wrong? No. Oh, I don't have my drill bits either. So I must have recorded my drill bit size wrong, and I don't remember the step down. Oh, that's why. It's 11/64, not. Oh, for heaven's sake. There. Thank you, Trey. Okay, so my apologies. So these are the specified hole diameters. This is what it should be. I, as the engineer, said, hey, I want it to be this big. Well, look what happened in reality. We actually measured the hole diameter. Is it exactly what I designed it to be? No. I took an average of all of our measurements and said, we got a 0.19 inch hole instead of 0.1875. Right? I list the error, which is how far off my measurement was from the specified diameter. What happens if I told you my tolerance for this part was 0.007 inches? Is this physical part acceptable?
Yes.
It is. Why is it, Micah?
Because 0.006 is what it is, and you said 0.007.
Yes,
So it fits.
correct. My tolerance said, hey, it's this diameter plus or minus 0.007. Well, we measured it and said, well, it was 0.0067 away. Does that fall within my window for tolerance? Yes, it does. So this is an acceptable part. What happens if this hole was for some port in an aircraft engine? And I said the tolerance is, hey, it's this dimension plus or minus 0.001, a thousandth of an inch. Does this pass? No. It's 6 times further away than what I'm allowing it to be. Again, as a kid's building block, I don't care about this. Right? This hole could be just fine. But for an aircraft engine, right? A part on an automobile, a safety feature, this is unacceptable. My tolerance changes. Over here, wait, which one were we closest on? Which one did we have the least error?
Block B. No.
Oh, this guy? Yeah, hole 3, right? We went to 2/1000th of an inch. This hole had the highest tolerance, right? This was a 5/16 hole. We were almost 3/1000th of an inch off. Again, if I list my tolerance as plus or minus 0.001, this doesn't cut it. The actual measurement does not fit within the criteria that I've given for my design. Now, if I'm building a kid's building block, and I say, you got a 1/4 inch above or below, well, we absolutely meet that specification. Right? We're 3/1000th of an inch off. That's definitely less than a 1/4 an inch. So the application changes your tolerance, and I want you to see, I used a 5/16 drill bit. I literally put that bit in the drill and drilled the hole, made sure it was nice and smooth. So I made it according to the design specs. But do you see how it's not actually what it should be? That's the problem with the production line. They got their tools and they're going to use their tools, but they don't work to perfection. That's not how the world works. So you have to figure out how much tolerance can I give them so that they can make my part and it still will work properly. Right? So that's what I wanted to show you by actually making a part, seeing if it matches what it should be, and understanding like variation happens. That's why we have tolerances. We set tolerance because we know you can't make things exactly, and you have to figure out how much room for error do you give so that your design will still work. Depends on the design, the application, safety risks, etc. All right, any questions on tolerances? Anything? Okay, so what I'm going to do, you guys have like half an hour. Again, I told you I had a short day because Friday was homecoming Friday. I wasn't going to try and wrangle kids' attention for 90 minutes. So you guys have the rest of class to just hang out. What I really would like you to do is if you got some work that you want to make up to me, right, you can show me now while I have a chance. Otherwise, shoot me that email. If you have missing work, please get that done. Wednesday at 2:30 is the grading quarter.
Come over there.
At that time, your grades will become permanent. I will not be able to change them. Don't let those zeros hang out there. Submit some missing work. What's that? Oh, you want section view? Section view is right here. Section view, right? And you're going to place some line symmetry. This one's real good. Cut it right down here. I'm going to place the section view over here, right? It's basically going to cut, and either these arrows are where you're going to look. So it's either going to look this side, or it's going to look on that side. That makes sense. So submit that to me. Submit it on Classroom. I'll get a notification and update it. Where is your work? Can you send it to me? Your other work?
Yeah.
Okay. Okay, good. I'll get a notification. Okay. Yes, you can. So, one, I want to remind you guys, I didn't say you can get your phones out, but I will allow you guys to get phones out if you'd like, to just hang out the rest of this time. Okay? Again, I need you guys, I'm gonna stop being so generous with that rule. It's gonna become an issue. Adrian?
Built like a pencil.
You're built like a throwing
Yeah. Because you emailed me, yeah. I have your grades up to date. Okay, and in PowerPoint.
You know that bat?
As long as that's
There's a
updated,
bat in this
that's
room,
good.
and they're trying to catch you with a net.
That was the only thing.
They're not gonna catch you with a net.
Yeah.
Where's the checkbook?
Yes, you can.
You're not even gonna hit it in.
And they can't leave the doors open.
So I need to schedule it.
No, they can't.
Yeah. All of that stuff goes in.
Exactly.
Right? 3 sketches,
Oh,
just
so
3
this
ideas.
is not this.
Correct. Yeah, remember the sketches were like sketch number 1.
Okay.
Literally, it's just waiting for it. So you give me 3 sketches of 3 ideas. You do your decision research.
Okay, so I've only been here since I've
Yeah, that's the only one we've done. So your next entry is 5. You're gonna put your sketches.
This man is
No, I'm saying that's the only one we did. Your next one will be 1 preset. So literally just like you can either do this page or one more, or this line. If you skip it, just put a cross through it. Right? You can say like, hey, I'm not using this.
You know
And
how
that's fine. And then title it, and then update, 137.
Okay, so do I need to put all this stuff basically here?
No. These things need to go in your.
Oh my god, I thought it was actually gonna die.
You have 3 sketches. Your design green is
I just said
the best design. Your material line, or that on sheet, your reach should have that, just put a copy of it, and then the concept, they should have that same sort of that, because that's a group thing. And then the last part is there to get a copy of the design group. Put all these things in here, take pictures, and attach them, and then attach a copy of that design. Again, your group makes it. Adrian and Nolan, you guys have that stuff, right? That you shared with my design. Yeah, like the design brief.
They're used to have
Okay. As long as you can submit all that.
Okay.
That's all I need. Where are the dial calipers, you guys? I need the dial calipers. I need those back.
Oh, there's one for you.
Okay.
By Adrian. Thank you.
You can fit in there. Thank you. Is there one more? Oh yeah.
I want to shut in there and turn it on.
Personally, though, I'm legendary.
Hey, Luke, from on Clash Royale, I got a Mega Knight from the Battle Pass chest.
Hey, you wanna know something sad? Or actually, like, really, really awesome?
What?
In gym class last week, I got a legendary out of the silver chest.
Silver?
Yeah, he got a night witch, and then I got a lumberjack.
That witch is actually really good. She does a lot.
So is Lava Head, I'm surprised.
Yes. I found that out the hard way that not everybody does that. Some of you, if you upload the part, import it, and if you wait,
And then once you
open it, it'll go right in. I think if you open it too quickly, it hasn't like finished, and that's the trick that I figured out. It's on this weird import viewer, right? That's why it's saying like, here's your file. Do you want to do something with this? And you have to go back to like your part viewer. I don't know. You did well on your project, though. On your project? I didn't think you did. Better than Hayden.